Thanks everyone for joining us for NextRev's Power Hour this Friday and sharing your lunch with us. My name is Jason Bland. I'm an applications engineer for NextRev, and I'll be conducting the Power Hour on top-down design. Now this top-down design, there's different industries use top-down design for different reasons. This is going to be more in the electronics arena, dealing with electronic devices and the surfacing aesthetics that kind of go into that industry. Okay, so you can see my contact information there. Question was asked earlier if the video will be available online, and we will be putting this video up on YouTube. There's limited access, so we want to just make sure that if you want to access to that video, just send me an email, and we'll make sure you get access to that. Okay. All right, so let's go ahead and start. All right, so this is kind of what we'll be going over today. We'll go over a few slides that kind of introduce NextRev. If you're not familiar with NextRev, some of the upcoming Power Hours, some of the courses we offer, and then we'll get into some slides on the master model technique. So in the electronics industry, we refer to the top-down design techniques as master model technique, and these are some of the steps that you go through to get to creating this type of geometry. Then I'll do a demonstration, and we'll field some questions that you may have. Okay, so NextRev is the premier value-added reseller VAR on the West Coast, and we're located in Santa Clara, California. We offer courses pretty much in any area in PTC software, and I'm going to cover a few of those just in case you're interested in maybe taking a course with us. We have quite a bit of experience. We've been doing windshield implementations and selling PTC software for over 10 years now. And you can find us at nextrev.com, where you can read up more on our business. Okay, so here's the Power Hours, some of the ones we've done in the past, just to give you an idea. We'll be doing a lot of these in the future. I'm going to be doing the top-down design there in bold red. We got Creo Simulate, formerly known as Mechanica, to analyze assemblies coming up next week. And then we have the Freestyle tool after that. And then we got some sheet metal, design of automation of your assemblies using the Creo options model. That's a new one. And that's really nice addition to Creo Parametric. If you have configurable assemblies, say like a PC, that's a good one to watch. Simplified representations, if you have assemblies that are on the large side, this can help you in that area. And then we'll talk about cabling, harnesses, and then we'll be doing the last one will be on Windshield 10. And here's some of the courses we offer. Now we do, these are probably the most common courses, update courses, intro, surfacing, and sheet metal. But we offer some of the more advanced courses as well. If you're interested, go to our website. And I'm going to have some contact information on the last slide that you can use to contact sales or tech to ask questions about those courses if you want more information. Okay, so the master model technique. Why do we care about doing this? When I start covering this, people start to ask the question of why would I want to go through the trouble of all of this extra work? Well, it ends up saving you time, basically, is the bottom line. Now, the type of parts that's used on, in this particular case, is consumer electronics. Typically, can also use it for parts outside of that as well, but they kind of lend themselves to, you know, high curvature surface type of product, and products that have multiple interlocking bodies. Okay, so you have a mouse, a computer PC mouse that has a top and lower half, and then you have buttons. Well, all of those follow a overall curvature that you want to somehow control from a, you know, from a higher level. Okay, instead of making changes at the piece part level, you can change them at higher levels and save yourself some time. That's the type of products you would use it on: cell phones, laptops. And what it does, what it allows you to do is basically design the overall shape of your assembly, of your mouse, for instance, or your laptop, and then kind of break that apart into all the different pieces. And then you can control the overall sizes of these electronics, or the, you know, say the mouse buttons and the slope of the mouse, you know, top of the mouse or whatever, by sharing that geometry down into the individual components and making the changes with the master model. And so that's what basically you're able to do, is you're able to change a bunch of parts, you know, maybe the curvature of multiple parts simultaneously. So the buttons of the mouse, the bezel of a cell phone, the top and lower halves of the cell phone can all be changed simultaneously. You're ensured of those parts matching up and interfacing with each other appropriately, and you're not having to go to each part and make the changes individually. So in the end, this will save us a bunch of time, okay, and a lot of heartache. So it's something that you want to kind of look at your product and decide, is this a good time to use this technique? Not in all cases what you want to use it, but for the styled surfaces, that's when you want to use this type of technique. Okay, so here's the steps. I think we have about 6 steps here that you could follow. First is creating the master model. Now, actually, when you start using this particular technique, what you're going to do is you're going to assemble most of the parts using your default constraint. It's easy to, a lot of reasons, it's easy to constrain it this way, and at least with the subcomponents, the body components further downstream in your model tree, you don't really have any geometry to use as a placement reference anyway. So, you know, just what you're going to do basically is build your structure out first, and you're going to put the master model in there at the very top or near the top, and then you're going to place, you know, your subcomponents, you know, the buttons of the mouse, the top and lower halves. All those subcomponents are going to go below the master model so that they can reference the master model. So as you know, with Creo, with Pro E, you are regenerating your model tree from the top down. So, you know, that's the reason why you need to order them this way. So when I'm saying, you know, internal components that it will reference, now if you know, typically we may start off with the styled surfaces of the master model, but a lot of times we have internal components. We have, you know, the electronics, the printed circuit boards, the mechanical of the assembly that we need to design our styled surface around. That's sometimes going to come before the master model, and then after the master model, you're going to have your piece parts that make up the exterior components. And when I get into the demonstration, this will be a little bit more clear. Once you get the master model in there, it's basically empty at this point. You're going to start adding a framework to it, and the framework generally has curves and datums in it. Okay. So Okay, so we start building a framework for a master model. Generally, this is curves and datums. Essentially, what you have is a skeleton, and this is the intelligent part of your design. This is why they call it top-down design, because you are placing all of the smarts in one part, and then you're sharing that down into the subcomponents. And those subcomponents are basically just piggybacked onto this master model. So now you can use a skeleton in the traditional sense. A skeleton is a special type of part that sits at the very top of the model tree. But it's not going to be good for a master model if you're going to be using the mechanicals as a reference. The mechanicals need to come first and then the master model. If you use a skeleton, that's going to place it above the mechanicals. So you just have to be careful with whatever technique you use. The assembly that I'll be using happens to actually have both a skeleton and a master model in it. So you'll see the structure and how that's done. So basically placing the intelligence at the top of your model tree and your design, and pushing those changes down into the structure. Okay. And then once we have a framework for our master model, we start creating surfaces to form the look and feel, the aesthetics of our design. Now, you want to consider design intent, just like always, and Creo and Creo. You want to think about what types of features to use. And there's two types of surface modeling. There's parametric surface modeling, which can get you most of what you need, and then there's freeform surfacing. You can use a combination of both, or you can start off with the parametric surfacing, see how far that gets you, and if you need curvature continuous types of surfaces, then you are going to have to jump into freeform surfacing, or formerly known as ISDX. So some of you may be familiar with that particular module of the software. Okay, then once you get some surfaces, basically all we've been doing at this point is working on the master model, okay, because once we get the master, that's where a lot of the work is done. Your subcomponents are just kind of copy of the master model. Once we get some surfaces in there, we might want to run some analysis of some kind on those surfaces to see if we have any types of kinks or bulges in the surfaces that we didn't intend to have. Make the improvements and rerun the analysis, and just keep going through that until you get something that looks the way you want it. Some of the tools we can use are the reflection analysis and shaded curve analysis, and there's a few other tools in there for that. Okay, and then we could also, now once we get the master model done, now remember we'll have some subcomponents. Say, in this particular case I'll be using a Norelco shaver. Some of you more experienced folks have probably seen this before. It's been around for a while, but it's a good model. It's a good one to show this type of technique. So in this shaver, what I'll have is top and upper and lower half of the shaver, and those would actually be individual components created. Now, what I need to do though is share the geometry from the master model down into those components. And I can do that using functionality called a publish and copy geoms, copy geometry or publish geometry. Publish geometry can be used, but typically it's not. It's extra clicks that you need to use. So copy geoms will help you in this regard. They're the most commonly used tool for that. Merges can be used, but there's a lot more work involved because they merge the entire master model into the subcomponents, and then you have to kind of chop them up and to leave only the surfaces that you need for, say, the upper or lower half. So it's not a very efficient way to do it. Copy geoms are the way to go here. Okay, so then once we get the appropriate surfaces and information shared down into each piece part, then we can complete the model. So we can refine the subcomponents, the components that are part of the body, and add more detail. And what I mean by that is you don't really want to add all the detail to the master model. You don't want to create a master model that has holes and chamfers and rounds and thickness and all these different things. You want to do that at the subcomponent level. Remember that the master model is just a kind of a framework to control the overall look and shape of your assembly, because that is what we're creating here, is an assembly. So what you're going to do is you're going to be adding a lot of that detail at the subcomponent level. So you got things like mirroring and merging, common things to do in industrial design, thickening these features, rounds, chamfers, and then colors. Okay, so let's go ahead and start the demo. What I'm going to use is this Norelco shaver. Okay, so this guy, let's just assume that this is what I've been given. I've been given a PCB, the head unit here, and this is what maybe the mechanical engineers have passed down to me to work with. I need to design some sort of, nice curved surface that's going to wrap around and look nice. So let's just take a look first at the structure of this assembly. Now I have a skeleton here. I'm not going to spend too much time on that, but just to say that you can combine. The skeleton in this case is locating these two assemblies here. All right, so it's a really simple skeleton. The other two assemblies I have, the top two, are the mechanicals. You got the head, and then you got the PCB. All right, so those are the ones. Now, remember I was saying that with the master model, it's not always going to be at the top, and that's because you're going to want to use information from these, because you're going to have to interface with this data here. You need the master model to come after it so that you can copy whatever information in these parts down into the master model. If it's way up here at the top, you're not going to be able to do that. Okay, so now let's look at the master model. Now you can also see I have some other components in here just to show you. If I do edit definition on this master model, you can see that it's assembled by default. Okay, so that's what you want to do with all of these parts. In fact, you're going to have the master model and then all of its subcomponents built out first. You're going to have your structure in place, and that'll give you a good visualization of where you're going to be going with this. So with the master model, and I already have some features in here, but I'm, just to save some time, I'm going to explain why and how these were added. Okay, so the first thing is I'm going to have to use some of the surfaces in this area and on the back side here in my master model to reference for all of the styled curves and surfaces that I'm going to be creating. So the first thing I do is I use a copy geom to do that. A copy geom copies surfaces, curves, and datums. Now you can look in here in the references section. You got your surfaces, curves, and then your datum. So if there are other surfaces in this model here, say the surface here, I can select that and it'll add the surface to my master model. And again, the reason why I'm doing this is so that I can have geometry shared into the master model. So right now I have two surfaces. Now if I look at the datum planes in here, I see that I have some excess material in here. I want to get rid of that because right now what I'm going to do is I'm just going to be modeling up half of this shaver and then mirroring it, ultimately mirroring it to the other side to save me some more time. So I put two trims in. I trim away the surfaces here with this plane and do the same thing with the back side of it. Okay, so we got those two trimmed, and then I'm going to add some points. The points are going to be used to create my curves. So I got these points in here, and these are just placed at the vertices of these surfaces here and here, and then also midway along this edge here. Okay, and then also here. So, and then once we have that, we're going to create another surface. Now this surface here is going to ultimately be used to project a curve onto. Let's take a look at this one. So this one was created using, a spline. right? And so if you're not familiar with the spline tool, it's here, right? I'm just going to come in and, start placing points, connecting the dots, right? Something like that. All right, so I'm not going to leave that in there, but that's kind of how this one was created. Simple as that. Had 1, 2, 3, 4 points, and I can change where those points are located to change the look and feel of the surface that I'm creating. So this surface is basically a construction surface. It's not going to be part of the final design. It's a parting line. It's going to divide the upper half and lower half, so it serves kind of two purposes here. Now, the other thing is I need to, ultimately what I'm doing is I'm building out the profile of my surface, and then I'm going to connect the dots with a surface tool that some of you may or may not be familiar with. So let me just turn these datums off here. So you can see the top profile and the bottom profile, those were created exactly like the surface you see here. So let me just go normal to my plane. You can see I put another spline in here with several points. I'm just going to, this where I'm just kind of eyeballing it, kind of move these points around, and then I would make the ends of the spline tangent to the geometry that I copied in from the mechanical portions of it, the head in this particular case, so that the transition into that part is going to be nice and smooth there. Or I can decide to do it as curvature continuous. Same thing with the bottom. Now here's where the third curve comes into play. So I have this curve here. Problem with this curve here is I want it to actually be a 3D curve. So what I'm going to do there is I'm going to just create it, place it on a plane, and then I'm going to project it onto this surface here. Now I have a 3D curve. It's turning in this way, and it's also curved in this direction as well. Okay, and I'm just going to hide this surface here for the time being so you can see what's happening, and I'll also be hiding this one because ultimately this one is not going to be used for our surface. Okay, now let's turn my planes on. I'm going to show you a couple more things where basically what we're going to be doing is adding. We're going to use these three curves, and then we'll be using this edge and this edge to create a surface. But we can also create an intermediate curve. One's going to be placed right in this location here. So I'm going to offset a plane. You can see the plane is offset from this plane here by 45. And then we'll add that mid curve there, where we place the curve on this plane, and we just kind of connect the dots there as well. So add some more points. The points are going to be used to kind of streamline the surface a little bit. You'll see exactly what I'm talking about there a little bit later, and then we have some other features that we're going to be adding to that. So basically that's it. There's your framework. We've assembled this. Now I just have the master model open by itself at the time being, but I'm going to basically use all the curves that were created here to use to create a boundary blend. A boundary blend is a surface that is used to go in multiple directions, 2 directions. So what I do is I go in this direction first. So I select this curve here, hold my control key down, and just kind of go through those 3 curves. So I have something that's looking a lot like what I want, but it's not complete because you can see here that these aren't quite meeting up. So next thing I need to do is add a second direction. I'm going to select here and then just hold my shift key down to pick that whole set of curves or that edge, and then hold my control key down and just kind of go through the rest of these. Okay, so I have those. Now it's looking a lot better, but I want to make sure that this surface is going to go into this. So if I right mouse click that white dot there, it'll allow me to go tangent into that surface that's been placed in there using the copy geom. Okay. Same thing down here. I'm going to make this tangent, and I'm going to make these 2 normal. So this will be normal to this plane here, and the reason why I want to do that is if I don't, when I mirror this, I'm going to end up with a raised area there right in the middle. So I'm going to say normal here, and I'm going to say normal here. All right. Okay, so let's take a look at that and see what it looks like. All right, so it's looking pretty good, but what I want to do, though, is I want to check this, kind of take a closer look at it using some analysis tools to see if I have any issues with the smoothness of the surface. Well, one of the things I can do is I can use this curvature tool, select the entire set of surfaces, and I can control the scale, of this. If it's not looking that good to me, I can, bounce it back and forth. The quality of the surface of the curvature analysis. And you see I have some raised areas in here. Any area where you have the curve is just a little bit out of whack, you want to go in there and fix that problem. So you can see here I have a problem in this area here. The other thing I can do, kind of a popular tool, is to use the reflection analysis or the zebra striping. And you can see there's an obvious issue here, some sort of little dip in there. Right, so let's fix that, and then we'll come back and check that area again. Now, with a boundary blend, what I can do is I can control where my transitions happen using these control points. So if I look at this way, so I have a point here, and really what I want to do is I want to connect that to say this point here. Now I added that point earlier. You can add it as you're doing this or just before. It doesn't really matter. And basically what I've done is I've taken out one of the, I guess, lines that was in there, making that little dip in there happen. So when I take that out and I do my analysis again, the reflection analysis, and I can see it smoothed out a bit. Not perfect. You still see a little bit of a ridge in there, maybe tangent, but ultimately I'd probably be going for curvature continuous in that case. It's good enough for what we're going to be doing today, so I'm going to go ahead and leave that as is. I could spend a lot more time on this, kind of refining the surface, and you will want to do that. But for the demonstration, I'd like to just kind of move on and show you a couple more things. So the last thing I want to do with the master model is add another surface. I'm going to add another curve. I'm going to actually put this curve and project it onto the surface here. Actually, do it this way. All right, so now I have another 3D curve, and that's going to actually form as a, if there's a button in this location or a non-slip pad that's going to be located there, it'll be a completely separate part. We're going to divide these into basically 3 separate parts. But you can see that all 3 will follow the same curvature. All right, so let's do that. Let me turn off the datums, and we're going to work our way back over to the assembly. And you can see that that surface has now been added to the assembly. You can see I have nice clearance in there. If I didn't, I can adjust the splines, and if I have an interference in there, I could clear those out. Now we'll be adding a wall thickness to this, so there's still potential for me to have that problem. All right, so go ahead and collapse these 2 parts and move on to the first body component, and we will resume this, and we'll see that we don't really have much in there. Again, if I do the edit definition, you'll see that it's been assembled by default. And the reason why is there's really not a whole lot there for me to use to assemble. It's easy, and build out your structure ahead of time. So there's some benefits to that. So what I want to do is use the copy geoms to copy information from this master model down into the upper part. Okay. So the first thing I need to do is activate the part. And for those of you that don't know what activating is, it's basically like opening the part on the screen by itself. Any features that you add will be added to this part. The benefit of doing it in the context of the assembly is that you will be basically able to reference geometry within the assembly. So you got to be careful with it because externally referencing could get you into problems. So we are going to reference the master model only in this case. So what we're going to do first, let me just actually go in here and unhide the split surface because I am going to need that surface. All right, so let me just kind of rotate this part back around here. Okay. And we'll collapse that, and we'll add a copy geom. The copy geom, you will find yourself having to turn this publish geom option off to use it. If you get into the copy geom and it's not letting you select things, you can see that there's nothing pre-highlighting for me. Turn this off, and then you should be able to come in and select surfaces that you want. Okay, so I got that surface. Now, within this same copy geom, what I want to do is grab the curves as well. You can right mouse click to toggle to the curves, and I can just hold my control key down and pick that. So I say OK. There's my first copy geom. If you look in the body upper, copy geom is located there. I'm going to add one more copy geom, and that's going to be this overall surface that you see here, that one. Okay, so now let's just open that upper body by itself. Okay, so now you see I have all of this information. Now, it's better to add more surfaces than you need because then you can always come in here and trim away the material you don't need. So adding more material is a little bit more involved. So what I'm going to do is start trimming away, and I'm going to actually create the upper portion from here to here. I'm going to use the trim tool to trim away, basically trim this in half using this parting surface here. The arrow is pointing in the direction of the surface I'm going to keep, and also what I'm going to do is turn off this keep trimming surface, and that's going to get rid of this parting surface. I don't need it anymore, so let's go ahead and turn it off in the same step. All right, so I got a couple of copy geoms, and I have a trim surface. So now I'm going to trim away this sketch. I'm going to trim away from the surface you see here. I need to select the surface first, trim, and then let's just pick that. Now it's pointing in the direction of the surface it's going to keep. Let's say I want to keep this small section in here, and you would want to have to do that at least in the case of creating the pads that will fit in this area. But we're not going to do that in the demo. Later on, downstream, that's what you would do for those pads. All right, so you have this surface here. We have half of the top of it, is what you're seeing. Now let's go ahead and mirror that. And we're going to mirror it about this plane in the middle of the part. And that's one of the other benefits to assembling by default. All of your planes are going to be right on top of each other, and you're going to be ensured of symmetry. Okay, now once I've mirrored, I want to do a merge. I want to merge those two and make them basically one continuous surface. And then I'm going to decide of, okay, well, now what kind of features do I want to add to this? All right. One of the things that you might want to do is add some thickness to it. So let's do that. I'm actually going to point that down into the part. Let's make it 2.5. I think we're working in millimeters here. And now you can see that this has got some actual volume to the part. Okay. And then after we've gotten some geometry in this top portion, we can come into these copy geoms and we can just hide them. That way they're not in the way anymore. Okay. All right, so we have this part. Let's go ahead and turn the shading on, take a closer look at it. So you can see this is looking pretty good. We can also analyze at this level too if we need to. Do some reflection analysis. All right, some zebra striping. Okay. Okay, so let's go back, and I'll do one more part. Go back to the shaver assembly, and I'm going to do the lower half now. All right, so the lower half doesn't really have anything in it at this point. We'll activate, and we'll do the same procedure. We'll use a copy geom to add the same exact surfaces and curves. I'm going to select there and then add the curve chain. Okay, so we'll add the parting surface, curve that we're going to use to cut out some material here. And then we'll do a second copy geom to add the surface from the master model there. Okay, and I'm just, if you see me pre-highlighting like that, it's what I'm doing is I'm query selecting and right mouse tapping until I get to the surface that I want. All right, so let's just isolate this part by itself by opening it and further refining this part. And we're going to do the same procedure here where we trim away some material. So I'm going to select the surface first, trim away. And in this case, we're going to point it the other direction. We're going to remove that trimming surface. And then we'll do one more trim. And I need to hold my shift key down to get all these curves in here as one. Okay, so now we have that, and guess what we do next? We do a mirror, just like we did before. All right, so we use this plane to mirror about that. All right, and then we can thicken it, do all sorts of things to this. We're going to move on from that so we don't spend too much time there. And take a look at this at the higher level. What you want to do ultimately is you want to come in here and just hide that master model so that you don't see all those surfaces lying on top of each other. And then we'll hide some datums, clean it up a little bit so you can see have the upper and lower halves, right? And then I would continue on with these pads that would fit inside here. I think there's actually a part that happens up here too, but I didn't model it in there. Now let's say this is inevitable that changes come along, and this is really where the power starts to show itself. Let's say that you have a design review and it's decided that you need to change the back portion of this. You need to make it, make it more, the dip here a little more drastic in this location. Now, the last thing you're going to do is come into each one of these parts individually and make those changes. What you're going to do is go into the master model, and I happen to know, if I name my sketches appropriately, that this sketch here controls that side profile. You can see right there. So what I'm going to do is look at this from my sketch view. And with this spline, what you can do is you can just kind of double-click it and then add another point in there. And I'm just going to push that in some. There might be an interference there, but we'll just try it and see what happens, okay? So go ahead and add that and say, okay. Now, you're probably noticing that really nothing has changed now, and that's because I need to regenerate this assembly and push those changes down from the master model into the upper and lower parts. Okay, so I'm going to go ahead and do that. I'm going to say regen, or you can, select Control-G, and that's a shortcut to regenerate your models in your assembly. Okay, and you can see that they push the changes down into those two parts. Okay, so I can open those parts by themselves and see the changes happened there as well. Just imagine that you have, 4, 5, 6, 7 parts in here that all need to be changed simultaneously. You just saved yourself a ton of time in doing that. And you're ensured that these parts are going to kind of meet up the way they should, right? And if you have some overlapping happening there, you want to make sure that those match up. So then we'd add the trim, the 3 parts for the trim, and we'd be done with this assembly here. Okay, so what I'd like to do now is just kind of, let's go back to the slides, and what I'd like to do is open it up for questions if you have any, and take those questions now, okay? At the bottom is ways of contacting us. This is the general line at NextRev. You can also contact sales or our tech department if you have any questions related to this or anything else. Then here's the websites of PTC and NextRev.